This is a pseudoscience iceberg. There is already one on Twitter, but I made my own, and this one is bigger, better, and something else with a B. It has everything from crystal healing and feng shui to Nazi occultism and Jakub the scientist, and everything in between. Like any iceberg, it's a list of stuff with the entries getting worse and worse as we go deeper. And trust me, it's going to get worse. Worse in this case means more and more deranged pseudosciences that are completely detached from reality. But it's more complicated than that because you can't really compare feng shui and looks maxing. One is basically harmless and the other one is basically hitting your face with a hammer to cause microfractures in hopes of somehow becoming more beautiful. And it's not the worst because there are way more harmful pseudosciences. I could also rank them based on how ill-informed or just simply stupid you have to be to subscribe to them. So instead of that, I use a sort of mixed ranking, and these are the categories that I made up. Pseudosciences, or not real pseudosciences. These are entries that many people would claim that are actually pseudosciences, but they aren't really. I will explain why in a minute. Right, I should also clear up what a pseudoscience is. It's basically a collection of beliefs or practices mistakenly regarded as being based on the scientific method when it's not. The level below that is The level below that is spiritual level. These are pseudosciences that are based on some religious or other spiritual belief. My idea was that if you already believe in these beliefs, then it will be much easier to convince you that the related pseudosciences that are based on them are actually real. Below that is the entry level, standard everyday pseudosciences that a lot of people know and a lot of people believe. Scam level, mostly medical or health scams based on pseudosciences. Entries in this category do not cause any harm directly, but can deter people from seeking actual medical help. Deranged level is more deranged pseudosciences, as the name suggests. It's basically the same as the previous tier, mostly medical and health scams based on pseudosciences, but unlike with the previous tier, the entries here can actually harm you directly. Things like radioactive toothpaste and actual medieval torture. Alternate reality level is even more idiotic pseudoscientific claims, often overlapping with conspiracy theories that are basically harmless. Which brings us to weaponized silliness. Things that are actually harmful. Very harmful. Not just to the people who subscribe to these beliefs, but to the broader society and people around them. Things like anti-vaxxing, conversion therapies, and my favorite, turbo-Slavism. But these aren't as harmful as the next tier, literal brain rot, which is a tier for the most harmful or most insane theories, or both. Stuff like Nazi occultism and Lysenkoism. So, I don't know, segue into the first tier. So, pseudosciences. As I said, many people categorize these things as pseudosciences, but they aren't really. Well, technically they are, but they were established before the development of the scientific method, so it's more like proto or pre-science. You can't really compare them with things like flat earth theory, the modern flat earth theory, where you have everything you need, including the scientific method and measuring equipment to come up with a good theory, and somehow you still end up with this. So because of that, I don't really use these entries as pseudosciences. Some other entries are not really theories, but just simple hypotheses. They were not really accepted in the scientific community, they were just ideas to explain something, but when more evidence became available, then they were just abandoned in favor of a real theory. Right, and another important thing. A theory in a scientific context is a model or a set of rules that explains how a system works and if applicable has predictive powers. Like the theory of gravity, which explains why my mother yells at me if I drop a drinking glass. And we can also use this theory to land spacecraft on asteroids, so it's actually pretty cool. In contrast, things like the flat earth theory does not explain anything and has no predictive powers. It's just bullshit. A hypothesis is basically what people mean when they commonly use the word theory. It's basically an idea or a proposed explanation of a phenomenon. It's basically the beginning of the scientific process. You just have an idea and then you make experiments to test if it is correct or not. It's basically the beginning of the scientific process. You just have an idea and then you test it. And if it turns out to be correct and you can also describe it using models or laws, then it can be promoted into a theory. And in this tier I also included superseded scientific theories. These are scientific theories that were superseded by a better one that explains more things or explains the same thing but more accurately, or both. So, first off, N-rays. In 1903, shortly after the discovery of X-rays, ultraviolet light and similar radiation and stuff like that, French physicist Prosper René Blondlot announced the existence of N-rays, N as in Nancy. It actually stands for the University of Nancy, so it's based on observing the change of brightness of an electric spark in an electric gap in an X-ray tube that he photographed. To explain this change of brightness, he hypothesized the existence of a new form of radiation, N-rays. And around 120 other scientists published in total around 300 papers on the stuff, but it turned out to be not real. Because subsequent experiments by skeptics showed that no such radiation exists and that the change in brightness was likely due to human error or incorrect measurements. And just after 2 years of the announcement of the discovery of N-rays in 1905, people outside the University of Nancy didn't really believe in the existence of the N-rays. So basically it's a disproven hypothesis. Morphogenetic field could also be called a hypothesis, but it's basically just an observation. The observation is that if you transplant certain parts of the embryo, for example, if you remove a forelimb bud and then put it somewhere else on the embryo, it will still develop into a forelimb. Or that if you add undifferentiated cells to anywhere in the embryo, they will develop together with other cells around them into some kind of organ. But they will develop into the organ that they are supposed to develop into. So if you transplant these undifferentiated cells from maybe the S region of the embryo into the brain region of the embryo, they will develop into a brain and not an S. To explain this, Alexander Gurevich came up with this concept. And as I said, this hypothesis does not really explain why this happens, it just describes that it happens. And as far as I understand, it doesn't really contradict modern embryology, which is way beyond the scope of this video, but what Alexander described as a field is basically just a bunch of signaling between the cells and some other complicated stuff that would probably take me weeks to understand and maybe hours to explain. Luminiferous ether is also a hypothesis regarding a medium in which light waves travel. You know, like sound waves propagate in the medium of air and waves propagate in the medium of the top of the ocean. One of the proponents is Robert Boyle, who sounds vaguely familiar from physics class, but I can't really remember him. Yeah, it's a false alarm, the name sounds familiar from Dishonored. Anyway, his idea was that ether consisted of particles responsible for things like light, magnetism, and other phenomena that are inexplicable based purely on a mechanical interaction, which sounds somewhat similar to the bosons of the Standard Model. You know, small little stuff or particles that are basically the force carriers in the Standard Model we use today. But in the Standard Model, bosons are moving particles, but in the hypothesized ether, the particles were stationary and their small vibrations or small localized movements cause stuff like lighting and magnetism. You know, like waves in the ocean. You know, the water is actually not moving, it's just wobbling in place. And the emergent property of these water particles is basically what you see as a wave. Anyway, the hypothesis was disproven by the Michelson-Morley experiment. Tooth worms are exactly what they sound like. They are worms in your teeth. It was once treated as a theory to explain toothaches, toothache, pain in your teeth, I can't speak English, and to also explain some other bad stuff that can happen with your teeth, like rotting, falling out, and stuff like that. As recently as the 18th century, despite having zero evidence for this supposed theory. It originated well before the scientific methods, so it's basically proto-science, so I put it here. But by the 18th century, they could have realized that this is basically not real. Phlogiston is, as Wikipedia put it, phlogiston theory states phlogisticated substances contain phlogiston and that they dephlogisticate when burned, releasing stored phlogiston which is absorbed by the air. It comes from the Greek word of burning up, and is basically an attempt to explain oxidization, mainly burning. This theory was created shortly after the development of the scientific method, but since it was really early on, maybe many scientists did not yet access or knowledge about the scientific method, so I would still consider it to be proto-science. But basically the idea could be traced back to Empedocles and Aristotle, based on their work of the four elements, water, fire, earth, and air. Stuff like that. Granitization is a simple one. I put it here because it was in the comment section of the original Iceberg, and it's basically just a hypothesis. It's a hypothesis to explain how granite, which is a volcanic rock, forms. And as you have probably guessed, volcanic rocks form through volcanic processes. So did granite. But the hypothesis was that granite was basically formed from other rocks through metamorphism. Metamorphism is basically solid rock changing chemical composition or texture without remelting. But granite, however, is formed from molten rocks, so humorism, like me, has nothing to do with humor. It's actually an ancient theory of how the human body works. Translated from Greek, humor can be juice, sap, or flavor. The basic idea is that the human body has four humors: blood, phlegm, black, and yellow bile, and that the extreme excess or deficiency of any humors can be a sign of illness, or any moderate imbalance in the mixture can produce behavior problems. So it's actually not vaccines that cause autism, it's phlegm. But what's phlegm? In the context of this theory, it's a general term to describe white or colorless secretions like pus, mucus, saliva, sweat, or semen. Also, phlegm is cold and wet. I mean, any liquid is wet, but it's wet in the context of the four elements from earlier. The four element stuff by Aristotle. Since it's cold and wet, it's associated with winter, and also phlegm is phlegmatic, as the name implies. Yeah, also the four humors were associated with certain behaviors or behavior patterns, and phlegm in this case is associated with phlegmatism. Blood was a source of energy for the body and the soul. It was believed to consist of small proportional amounts of the other three humors, and it was hot and wet, so basically spring. Don't ask me why, I don't understand it either. Blood was associated with sanguine nature, or enthusiastic, active, social, for those like me who don't know the meaning of sanguine. Yellow bile is the stuff from your gallbladder, or just vomit and feces. It's hot and dry, or summer, and it's associated with choleric nature, or being ambitious, decisive, and aggressive. I also had to look up what choleric means. Black bile is cold and dry, and it's autumn. So it's basically melancholy, which derives from the Greek word for black bile. Melaina chole, or something. I didn't listen to it on Google Translate, so I don't know how to pronounce it. Yeah, and it's secreted by the spleen, whatever that is. So this one would be a proper pseudoscience, because it has rules and a system to explain certain things. Health, in this case. Doing all this without any evidence or real science being performed, but again, this theory was developed around 500 BCE, so yeah, it's a proto-science. Alchemy comes from the Arabic word of alchemia. It's an ancient branch of natural philosophy, a philosophical proto-scientific tradition. Or if I want to describe it by my own words and not just read Wikipedia, it's basically chemistry, but older and more esoteric. But that's an oversimplification. The goals of alchemy was to create the elixir of immortality and panacea. Panacea is basically a medicine that can cure all kinds of illnesses and sickness. And also to turn lead into gold, which is kind of hard without a particle accelerator, of which there weren't so many back in medieval Europe, or just generally in the medieval world. It also relied on the ancient Greek concept of the four elements I have discussed earlier, and it also developed some basic laboratory techniques and recipes. And as I understood, there weren't some concrete recipes, but every group of alchemists came up with their own and top secret recipes to create, well, basically the medieval equivalent of food supplements. Of course, today we are much more civilized, and instead of wasting our money on useless food supplements, we only buy horse electrolytes for some reason. Also, apart from chemistry-like stuff, it also included some esoteric practices, like the magnum opus or great work, which was the perfection of the human body and the human soul, which actually had some chemical recipes, but it's basically when a schizoposter on 4chan tries to create a pipe bomb. Cold fusion is regular nuclear fusion, but it's cold, somewhat around room temperature. The reason some people may refer to it as a pseudoscience is a claim by Stanley Pons and Martin Fleischmann that they have observed excess heat and nuclear reaction byproducts, namely neutrinos and tritium, in one of their experiments. The experiment involved electrolysis of heavy water on the surface of a palladium electrode, and it received a lot of interest because, well, it's basically free energy. But other scientists could not reproduce the same results, so there was also no theory that could explain the results they got, so nothing really came of this experiment. It never really went on to become an accepted scientific theory, and it just remained a strange experiment. And after many other scientists recreated the experiment but could not reproduce the same results, almost everyone dismissed it. However, there is another way to do cold fusion called muon-catalyzed fusion, which uses muons. It's basically an electron but beefier. Please don't say this to quantum physicists because they will have an aneurysm. Aneurysm. This. So muon is basically a particle similar to an electron in the sense that it also has a negative electric charge, just like an electron, but it's 207 times more massive than an electron, meaning that through some arcane and hard to understand quantum mechanical processes, if you replace one of the electrons in a water molecule with a muon, then the nuclei of the water molecules will get 186 times closer than otherwise, meaning that nuclear fusion can take place at a significantly lower temperature than otherwise. This means even room temperature or maybe even lower. This would be pretty fucking amazing because, again, it's basically free energy. The only problem with this, it's really hard to create muons. What I mean by that is that it takes much more energy to produce muons for this reaction than you can get out from the fusion itself. Another problem is even if you create the muons, their mean lifetime is about 2.2 microseconds. But hey, at least it works on paper. Again, it's not real pseudoscience, the experiment stuff is just a bad experiment, and the muon stuff, as I understand, is real and is supported by theory, is just we lack the engineering skills to achieve it. Miasma is Greek for pollution, but miasma sometimes is also called night air. It's a pre-science theory that states that bad air, especially emanating from rotting organic matter, is responsible for some epidemics, like cholera, chlamydia, and the Black Death. Apart from this, some academics also suggested that this theory should be extended to other smelly stuff. For example, inhaling the odors of food could actually get you fat. It originates from Greece from around the 4th century BC and it was accepted in Europe and China until 1880, when it was superseded by the germ theory of disease, which wasn't an easy task to do given that some people were thrown into insane asylum for suggesting that maybe doctors should wash their hands between delivering a newborn baby and fucking around with cadavers. Lamarckism, or Lamarckian inheritance, is a proposed idea that would explain evolution. His idea basically was that offsprings inherited the acquired characteristics of their parents. Basically this means that if your parents went to the gym before you were born, then you would be born stronger, and if they didn't, then you would be weaker. And unlike for Darwin's idea of inheriting genes and stuff, which is an oversimplification, there was no evidence found for Lamarck's idea. So Darwin's idea later became the theory, which then was further developed into today's theory of evolution. But if we treat the definitions loosely, then there are some things that could be interpreted as Lamarckian evolution. And these are transgenerational epigenetic inheritance and somatic hypermutation and reverse transcription to germline, which I have no clue what they are because, again, it will take around 2 or 3 weeks to learn everything about it and another 1 hour in this video to tell everything about it. But there is also the Baldwin effect, which, if I oversimplify it, is basically the behavior of the animal resulting in the selection of their genes. But I could also say that the genes affect the behavior of an animal in some ways, so yeah, I'm probably not the best source for biological stuff. And the other one is whole genome theory of evolution, which is basically cooperation with symbiotic organisms. As I said, they are way too complicated for this YouTube video, so they are just here for the somewhat funny names. And despite that Lamarck's idea was abandoned, even shortly after it was disproven, there were some people who pushed this theory, which didn't really end well, and the results of these experiments are in the bottom of the iceberg. Crypto explosions were explosions of unknown cause, used in geology to explain certain structures. So these structures were circular, and there was a strong contrast between rock deformation inside the structure and somewhat intact landscape around it. Also, it showed evidence that material from inside the formation or the structure was either blown outside or otherwise deformed. Also, there were no volcanic formations or volcanic rocks inside these structures, so it was pretty hard to explain them. And one of the hypotheses was some sort of unusual gas explosion, which, given the evidence that they had so far, is somewhat good and okay. Again, it wasn't really a theory, more like a hypothesis, and it was pretty much pre-science, so yeah, not really a pseudoscience. Also, the structure I described is basically a meteorite or meteor, I think it's meteorite crater. And yeah, many of these structures were later confirmed to be craters of stuff impact. Also, the articles about crypto scams and the recently founded Department of Ketamine made it pretty hard to research anything with the word crypto in its name. So yeah, that was pretty fun. Neptunism was a hypothesis regarding the formation of rocks through the crystallization of material from the oceans of the early Earth. A rival hypothesis was Plutonism, which proposed that these rocks formed through volcanic activity, which later was confirmed, so Plutonism didn't really become a theory, but it was further developed into one. With other evidence and other stuff, it got more complicated. Again, I wouldn't really say that it was a pseudoscience. It was basically one of two or maybe more ideas describing how the rocks in the Earth formed. And given the evidence and further development of geology, later this idea was abandoned, so yeah, it was basically a hypothesis. IQ, as you probably know, is an attempt to describe and measure human intelligence. It's generally good, but not really perfect. The tests used to measure IQ are basically just measuring your pattern recognition and not much else. It doesn't measure, for example, your memory, which could be argued is part of human intelligence. It also doesn't measure creativity, and by creativity I not only mean like artistic stuff, but also creating inventions that are useful for humanity or solving problems in a creative way. Thinking outside of the box and other bullshit buzzwords. It also can measure emotional intelligence and interpersonal skills, which you could discard as woo-woo bullshit, but given that humanity is living in bigger and bigger societies, it's pretty important, and could be argued that it's part of human intelligence. But given these shortcomings, otherwise it's a reliable way to measure what it actually measures, which again is basically pattern recognition. So it's not really a pseudoscience, and the reason I put it here is because many people are misusing it. By misusing it, I mean on the good end, giving it more importance than it actually has, and on the bad end, it's used to support other pseudoscientific ideas like racialism, which is basically scientific racism, because apparently there is such a thing. The last one is Newtonian physics that I only put here for fun, because I haven't really seen anyone mentioning it as a pseudoscience, but it's still worth talking about, especially given that other superseded theories, even if they were pre-scientific theories, were also included in the iceberg. So basically Newton's work, especially on mechanics that you have learned in high school, is basically wrong. Well, it's wrong in a sense that it's not very accurate. I mean, it's still accurate that you can use it to build planes and bridges and land spacecraft on asteroids, but there are certain limitations on this theory. And if these limitations are a problem, which they actually are for some implementations, then you want to use a more accurate theory, namely Einstein's theory of relativity, which was proven relatively early on in the 1930s, where it gave a more accurate prediction about the orbit of Mercury than Newton's idea. And we actually need this accuracy when it comes to GPS, because GPS is basically a system that measures how much time it takes for a signal from a satellite to arrive to your GPS receiver, and it calculates your location based on that. The problem is that due to the gravitational effect of Earth, time passes differently up near the satellites and down here on Earth. Something that Einstein's theory accounts for while Newton's doesn't really. So yeah, basically a lesser known fact that Newton's theories were superseded by another one. So given how you define the word, it's not necessarily correct. But we actually know that even Einstein's theory is wrong in the same sense, mainly because it doesn't really go well together with quantum mechanics. And both Einstein's theory and quantum mechanics is basically proven theory because both of them accurately describe how things works and are useful predictive models, but they don't really go well together. There is actually a lot of smart people working on sort of putting the theories together and making a better one that actually describes relativistic systems and also quantum mechanics, but as I heard, it's not really easy. But anyway, hopefully someday both of them will be superseded by a better theory. The point is that we already know that both of them are not entirely accurate. Anyway, things will start to get really weird in the next year, in the next video. So thanks for watching, stay hydrated and please subscribe. I need to reach 1,000 subscribers so I can make money from YouTube and spend that money on my bookshelf, which has no books. That's why I need the money. And for whiskey.